Today we're going to remove a massive amount of metal. G'day guys, Matt from Hal Heavy Duty. We're an Aussie machine shop that specialises in the drilling industry. Today I'm breaking out all of the big guns, and this is a rush job, so I have to get this done really quickly, and I just wanted to catch it because these are the ones where I'm blasting out a lot of metal using big tools, heavy cuts, and I find this so therapeutic for my soul. There's something about taking heavy cuts, chips flying everywhere, and just turning a big chunk of steel into something beautiful that I don't know, it just lights up my day. So anyway, I'm gonna share it with you. I hope you guys enjoy it. Let's get cracking. Fat boy. We're going to rotate it around as we cut this time.
Yeah.
This will be interesting to see if it's better than that. This might work out all right. Let's check it out. See you, buddy. Bye. That might have come up a minute. Only one way to tell, gang. Keep coming, yeah? Good girl, Jennifer Lopez. Anyone comes to steal the lathe, you bite them. Here's the tools we're going to be working with today, gang. W&MG, my little favourite go-to. We're going to take some fairly heavy cuts with that. Top-notch exterior threading tool, 80mm HTS, and of course my old buddy Kong, 63mm bar, that's 2.5 inch, with a big CNMG insert. Same deal, taking 5mm cuts with that, so let's get cracking. You can see from the cut marks there, rather than just trying to lop into this big billet, it measures 320 in diameter, 12 inch. We rotated the billet as we were cutting rather than just lopping into it. On a previous video, it's probably, I think, been the channel's most popular video, it cut right off, and that answers the question. It's just user error, Matt being lazy. Anyway, that seems to have cut pretty bloody good. Then we'll face him off, turn him down, flip him over, and get into it. That's pretty good, eh? Way better than last time. Rightio. I am going to face the rest of this side off, turn down the rest of this. It just makes it easier for me to grab it and maneuver the billet. I'm going to cut it off later anyway, but we'll just make it a nice clean billet. Then we're going to send the HTS drill all the way in up to with an inch to spare. About 205 mil in, about 8 inches or so. I think it's 8 inches, something like that. And then we'll send in Kong, hollow it out, and then we're going to flip these around, grab it here, put a center up it, and then thread the outside. That's how we're going to do it. Let's crack on. Now normally when I'm using these HTS drills, I will leave the coolant on the whole time. But today, just so that you can see how awesome it is, I am going to switch it off briefly. It's not going to hurt it. I wouldn't do the whole bloody thing, but I'll just let you see, and then we'll put the coolant on and we'll crank it out. All right, let's crack on. And we just use a simple G code for U-drills. So just saying go X300 Z500, tool 35, RPM 350, spindle on, go to X0 Z5 so it travels straight in there. I always set the tool up before I run it so it's no drama. Coolant on, gently go at a speed of 0.05 to Z-7 and then up at a 400, which is the max power RPM, or 409, but S400's fine. Go to Z-210 at a feed of 0.14, which makes it chip, and it gives me just a tickle with a power lift, and then pull out to Z5, spindle off, coolant off, back to where we started. I'll put it in the comments if anyone wants it. Works well. And because it's, you know, G0, like rapidly going to Z5, I've always got my hand on the feed control, just because I don't like it racing in. I always just for safety's sake. So there's never going to be a bang. Go baby go. Serious metal removal, eh? Beautiful. Oh, good job, buddy. Good job. Weapon. Oh, Kong. I know you're itching to get in there and have a crack, buddy. Let's do it. We have got a whole lot of metal to remove, and this is the fastest way to do it. And there's no way to use holo or anything like that, because this needs to have a solid end on the back. Can't trepan it, can't do anything, you just got to drill it and then hog it out, and that is exactly what we're going to do. Here's the cutting data. So I'm going to be using 120 meters a minute, constant surface speed. I've maxed the RPM out at 500. It does go faster, but I'm spinning a lot of weight there. 5 mil depth of cut. Finishing cut, I'm going to make that actually 2.5, it does that better. Z-axis finish amount 0.15, and that will chip nicely at 0.27 millimeters per revolution. I'll put the imperial in the screen in the bottom there. That's what we're doing. You can see that is what we're going to be hogging out. It is a lot of material. Righto, let's crack on. Suerte, loco. this is the time usually, like when the lathe's just hammer and tongs going for it. This is where I'm usually chatting to you guys in the comments, and I really do thoroughly enjoy chatting to y'all. My grandmother was Texan, so that's why I got some weird idiosyncrasies to my personality, but grandma being Texan, granddad being Canadian, you know, it's all very chilled out. And a little bit not. This is just some of the stuff that's going into the big lathe after this little rush job. That's the matching half there, I'll show you at the end, to what's currently in the lathe. That will be a tool joint. That will get repaired. That's going to be something totally different. There's some more tool joints for more rods. We've got a bigger set just been ordered as well, so never a dull moment around here, gang. It's just always on like Donkey Kong. Anyway, let's see where we're at. There's a lot of metal removed. Cooking. Fat chippies. That insert's going to be fucked. But the job's done. Not bad. Not bad at all. Hey man. Supervisor's watching, Eddie. Alright, I'm going to reverse the jaws, pop in a cone center, and then we're going to hog out the outside and thread it. I don't normally need to do this, but we're going to do a get rid of some swarf. We pretty much filled the lathe, and I'm going to fill it again. That is one big pile of swarf. I'm going to index the insert before we even get started. And in case anyone's wondering, I get asked this a bit with coolant, or cutting fluid. When I'm generally machining in this and not filming, I'm running coolant. It's just when I'm filming it for you guys, this insert costs about $9. I think we bought them on special. It'll still cut without cutting fluid. It just reduces the life of the insert. Without running cutting fluid, it means I don't get a coolant bath. On the drilling in this video, I showed it to you. I almost never drill without cutting fluid. I just wanted you to be able to see it because I think it looks really cool. It won't harm those inserts. It was only done for about 8 seconds, but I actually paused it, let them cool, and then ran coolant so they don't get heat shock. Anyway, that's a fresh little insert corner. Let's do it. Cutting data, 150 meters a minute, 4 mil depth of cut, 1 mil for the finish, feed rate of 0.33. I did 0.25 on the finish. Good luck, little buddy. This thing's gonna go off like a frog in a sock. Filling her up again. All right, let's finish him off. Beautiful. And just before I take him out of the lathe, because I'm nice, I'm just going to put a chamfer on this edge here, and we're done. So I don't mark it, just to put a bit of pressure on it. Don't really need to, it's not going in. I just feel safer. And we're done. Let's go weigh you. Look at that. There you go. I actually understated it on the thumbnail. Weighs 92 pounds. This thing's still accurate. It's older than me. I used to get weight on this when I was a kid. It was grandma's. But we've kept it and I can't bear to throw it out. 92 pounds, hey? That's a big lot of weight loss. From 330 down to 92. Aggressive metal removal. And of course, for my metric part of the world, or like me, that's 42 kilos, just under 42 kilos. So it's gone from 150 to 42. Nice. Let's get you over to be welded. All right, now, there's actually a pin and a box been made. All right, they're both blind, so there's no hole all the way through on both of them. Let me know what you think they're for. Very specific purpose. And you will get to see it in the next video. There'll just be a short snippet of what we use these for. Very specific purpose, and they're not testers. See who gets it right. There's still a little bit more to be done to them, but it's not in the machine shop. It's over in the fab shop. That's your hint. Oh man, I'm really happy with how that turned out. Guys, I appreciate you. Thanks to everyone who likes the videos straight up, who comments on them, shares where you're from. If you're new to the channel, let me know in the comments where you tuned in from, because I get a genuine kick out of knowing where in the world you are watching these videos. But anyway, guys, that's it from me. I appreciate you. I will catch you in the comments, and I'll catch you on the next one. What's in there, Teddy?
It's a digger.
Oh, that's a big digger, isn't it?
I know, it's so fun.
Who painted it?
Dino painted it.
No, Stumpy painted it.
No.
Stumpy painted it. Wow, did he do a good job? Should we inspect it?
Oh, no.
Any curtains, any runs?
Hop on.
Oh, you want to hop on, do you?
Hop on.
It's a big paint bay.
Hop on.
This is why they did it.
No more bucket. No more bucket.
The bucket's still off. They need to put the bucket on. Who's got to put the bucket on, Teddy?
Dino put it.
Dino put the bucket on, okay.
Yeah.
What about Cookie? That's Mr. K-Man. K-Man's here.
And hop on.
You want to hop on?
Yeah.
Do you want me to pop you in?
Yeah.
Okay. Whose digger is it?
That's my digger.
Oh, is it Teddy's digger, is it? Hop out, Teddy?
No.
Oh, do you want to say goodbye, everybody?
No.
Say see you next time?
See you next time, everybody.
You're such a good boy, mate. All right, let's keep playing, hey?